All right, so let's look at how we balance chemical equations by using coefficients and then determining a molar ratio based on the coefficients we use to balance. Okay, that all starts with understanding why we have to balance to begin with. The law of conservation of mass says that matter can't be created or destroyed. So if we're looking at a reaction, that's saying that whatever reactants we start with have to show up on the product side somewhere. It is just a rearrangement of atoms. It's not changing how many there are. So let's look at this really simple reaction right here. We can see our reactants are H2 plus O2. And so you can see here a subscript that tells me how many atoms are in the molecule or how many atoms of that particular element we have. Here H2 would look like this. We have O2, and this yields H2O as a product. So you can see here the subscript saying we have 2 hydrogens and 1 oxygen atom in that molecule. If we listed it out at the yield arrow, what we have right here says that we have 2 hydrogens, 2 oxygens, and on the product side 2 hydrogens and 1 oxygen. So that appears not to follow the law of conservation of mass, but we know that that can't be true. So we need to fix this somehow. Our gut instinct might be just say, oh, add a little subscript over here, but we can't. If we added a 2 as a subscript there, that's hydrogen peroxide, completely different than H2O. So we can't change what is there. We can only change how much of it we have. And that requires us to use something called a coefficient. Coefficients, these are big numbers that we can put in front of formulas. So here, here, or here. And when we do that, that number can be multiplied by all of the subscripts in that particular formula. Okay? So let's look at how we can fix this particular reaction using coefficients. Okay, so notice here it's the exact same reaction, except note that I have used lines right here just to show you where the possibilities of a coefficient are. Because again, we can't put it in the middle of something, and we can't add it as a subscript. The coefficient can only go in front of a formula. And when we do, it has to multiply. So you're looking at what is uneven. So when we assess this to begin with, we know hydrogen looks okay on both sides. But it looks like we've lost one of these oxygen atoms. So let's try to fix this one first. So I need a coefficient that when I multiply it by this 1 here, it will get me equal to 2. So that's an easy one. 1 times 2. So 2 would be my coefficient. I'm going to find this oxygen. Oxygen is locked up in a compound. The only option is put a coefficient here though. So yes, that will also change the hydrogen. But it's okay because we can go back and forth. So let's try that. Okay, so let's say that we put the 2 here and distribute. 2 times 2, this becomes 4. 2 times 1. All right, so we fixed one problem and created another. That's okay. Like I said, it's balancing because we can go back and forth. If we have 4 hydrogens on this side, I need a coefficient that I can multiply by 2 to get me equal to 4. Easy, 2. I'll find hydrogen. Hydrogen is not in a compound. So what coefficient I put here only changes the hydrogen, which is good. 2 times 2, 4. If we step back, hydrogens are equal now, oxygens are equal now. If you don't have a coefficient, that means the coefficient was an understood 1. So now what this is actually saying, so again, for my visual people, this is saying that I have 2 H2s. 1 O2, and then it's saying that I have 2 of the H2O molecules. So if we take a step back, 2 is 4. Oh look, they all 4 showed up. 2 here, 2 here. This is balanced. My molar ratio, all I'm going to do for the molar ratio is pull out the coefficients in front. So we have a 2 colon 1, 2. So for every 2 H2s and 1 oxygen molecule, I will produce 2 H2O molecules. Okay? So now let's look at one that's a little bit harder, but again, still really easy. Okay, so for this one, we're going to start off the exact same way. I'm going to list all of my elements on both sides. Notice I've listed them in the same order, even though they don't show up in the same order, because I want to be able to easily compare them. Okay, so my first step, I'm only going to list what is there. Aluminum, 1. Iron, 3. Nitrogen, 2. On this right-hand side, everybody's a 1. So you have a couple of places that you can start. We're not going to start with aluminum. Let's just start with, we'll start with iron. Okay, if I have 3 iron on this side, I'm going to want this side to be a 3. So what number times 1 will give me 3? 3. Find iron on this side, because this is the side you want to fix. So the coefficient will go on this side. Iron's by itself, which is good. 3 times 1, you now have 3 irons on this side. Okay, so now let's fix nitrogen. Nitrogen's 2. This side, we need to multiply by 2. Nitrogen's locked up in a compound. That's okay, but the only option is to put it in front, which means this will also change aluminum. 2 times 1 is 2. 2 times 1 is 2. Balancing act. What number times 1 will get me equal to 2? The answer is 2. Aluminum by itself. So any number I put there will only change aluminum. Equal, equal, equal. We don't have a number here. It's an understood 1. So my ratio, 2, 1, 2, 3. And we're good to go there. So now let's look at one of the ones that has some elements that are split up. Our faves. Things like combustion. Okay, so there are lots of different ways that we can tackle this. I'm going to show you a way that I think that most people will be successful. Carbon, there are 3. Hydrogen, there are 8. 2. So now notice, I have still listed it as carbon, hydrogen, and oxygen. Because, again, they should be the exact same elements. I've listed them in the same order. Oxygen, though, is split up over here. But it is still oxygen. So at the end of the day, the total count of both of those oxygens should still equal this 1 oxygen. Okay? So we're starting off with 1 carbon, 2 hydrogen, and then I'm going to list them as 2 plus 1. Whenever I put a coefficient here, it'll change this oxygen. Whenever I put a coefficient here, we change that oxygen. Okay? In situations where an element is split up, never start with those elements. Okay? Because they're obviously locked up in both compounds, so anytime we change these are inherently going to change. So we're going to see if they can fix themselves a little bit, make it a little bit easier for us. So let's start up top with carbon. We have 3 carbon on this side. So what number times 1 will give me equal? Okay? 3. 3 times 1, 3. But that's also attached to this oxygen. So we have 3 times 2. This oxygen changes to 6. Notice this one doesn't change because we don't have a coefficient there yet. Hydrogen's 8 on this side. We need to multiply this one by 4. When I do that, 4 times 2, 8. 4 times 1, this changes to 4. But again, there's still oxygen, so I have to add these two together. 10, a nice even number, and that's the goal, because anything times 2 is going to give me an even number, okay? So, what number can I multiply by 2 to make it equal to 10? The answer would be 5. 5 times 2, 10. Even, even, even. There is no number here. That means my ratio will have a coefficient of 1 there. So my ratio is 1, 5, 3, 4. Alright, so if you want to try this one, you can take a second, pause the video, try it yourself, and then unpause it, and you'll see it solved. So on this side, we're just going to list out again. We have 1 hydrogen, 1 fluorine, 1 calcium, but then here, this has O and H. Again, H is something we've already seen. This subscript has to be distributed to each of the elements within the parentheses. Not calcium, just what's in the parentheses. So technically we have 2 times 1, 2 oxygen. 2 times 1 is 2, but we already have hydrogen listed. So you'll see I listed as 2 numbers, just like I did in the combustion. On the right hand side we have 2, we have 1, we have 1, and we have 2. I'm not going to start with hydrogen. It's split up on this side. Makes it difficult. Let's see if there are some other things we can fix that will help us out. Okay? So we have 2 fluorines on this side. What number I can multiply here? 2. Find fluorine here. That means that this coefficient is a 2. 2 times 1, 2. 2 times 1, this hydrogen will be a 2. All right, so now let's see anything else that's uneven. Again, avoid hydrogen until very last. Okay, we have an oxygen here. 2 on this side, 1 on this side. Find oxygen in the problem. 2. Distribute. 2 times 2. There's only 1 hydrogen on this side, so that's 4. 2 times 1, 2. Even, even, even. There are 4 here. 2 plus 2, even. They don't have numbers. That means they're understood ones. My ratio, 2, 1, 2, 1.